Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kulika and I will be your host for today. Just a few reminders before we start with the webinar. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window, just by clicking on the Ask a Question button. Please be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you entered it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Sentinel forum at aka.ms/Azure Sentinel community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security-webinar-feedback. I would also like to invite you to join our public community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. In our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews at aka.ms/securityprp, request features, give feedback, review our product roadmaps, register for events, or just join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Sharon Xia will guide us through the machine learning detections in the AI infused with Azure Sentinel SIEM. Sharon is a principal program manager with Azure Sentinel team, and without further ado, I will turn it over to her. Sharon, the floor is yours.
Thank you. Hello, everybody. This is Sharon. So I'm going to talk about what we have, how do we use machine learning for cyber defense, especially in Azure Sentinel. Like Varun said, our team builds machine learning threat detections in Azure Sentinel and actually in other Microsoft security products too, like Azure Defender. Today, I'm going to focus on Azure Sentinel. Let's get going. So, you guys can post questions, and I will focus on the presentation and the demo and answer all the unanswered questions towards the end of the presentation. Azure Sentinel has four, at a very high level, has four key capabilities. Collect the data and detection and threat hunting for malicious activities and investigation and response. What I put AI in those detection and hunting and investigation, which means, we have artificial intelligence in those two areas at the current stage. So before I dive in the feature, I would just want to have a definition, put together here and everybody clear about when we talk about AI and the machine learning and what are, the difference. So machine learning, AI basically is, we're talking about machines or computers that mimic cognitive functions that human associate, learning and the problem solving. So machine learning, we are talking about specifically, the algorithms that improve automatically through experience. So it's a subset of artificial intelligence. You don't, not like, you don't really, in some scenarios, you don't need like the machine learning algorithm, right? You can use heuristic or statistical algorithms to achieve artificial intelligence. So I just want to make that clear to everybody here. So this slides show our strategy of using machine learning, helping modernize security operations center and for our customers. The x-axis is the customer's investment in machine learning, and the y-axis is the customer security experience. With years of building threat detections using machine learning, we know good quality, high fidelity threat detection requires both security expertise and data science expertise. So we are committed to help our customers to go through this machine learning maturity journey in your organization. So we have three major pillars. On the left is out-of-box built-in machine learning analytics in Sentinel. And on the far right is we built this bring your own machine learning platform that for your data scientists to build threat detections, build ML models on your data that only visible to you, and you are the expertise for this data. And in the middle, the SOC ML is we build the machine learning models that end the customer experience that enable security analysts with limited machine learning knowledge or with no machine learning knowledge to customize the out-of-box models and to improve the signal-to-noise ratio in your environment. I'm going to dive into those in a second. So that's like the high-level structure we have. Now we look at the data layer, from another angle, how the data layer is structured in Azure Sentinel, and how we use AI and machine learning in these areas. So you have raw data ingested in Sentinel, and we use AI, including machine learning, building metadata, enriched data, and observations on top of the raw data. And then, we build insights and anomalies on top of those two layers. On top of all these information, then we're able to build rule-based or ML-based detections, threat detections, and do threat huntings, etc. So this is, the kind of our strategy and the practice in Azure Sentinel on the data layer. So now I'm gonna look into what we have in the out-of-box machine learning models. UEBA. So we have this UEBA model, right? And there are multiple places we use machine learning to provide insights for our customers. For example, user blast radius is one of them. We use machine learning algorithms to look at the user permission in your Azure resources and build the score of the idea is if this user is compromised, what's the impact? What's the damage it can do? The higher impact, the higher blast radius score. So, for example, Satya is the CEO, right? If his account was compromised, then the impact to Microsoft business is extremely high. So his blast radius score is much higher than my blast radius score. Or another example is if a user, Bob, is an tenant admin or subscription administrator, then if Bob's account is compromised, then the impact is equivalent to like in the on-prem world, like the AD administrator's account is compromised, right? So that's one of the example we have in Sentinel use machine learning. Another example is there are user insights like the entity page, certain user insights also use machine learning to build that. Another example is user peer metadata. So we cross through Azure Active Directory and use machine learning algorithm to figure out the peers of a user. It's not just like the user in the same security group. And there is a bit of calculation learning through the past user behavior in that. So you can see there are two tables in Sentinel. If you go through, let me just show you where are they in a demo environment. So if you click on, go to the logs and click on Azure Sentinel UEBA, and you see we have 4 tables, right? And the behavior analytics, identity info, user access analytics has the blast radius information, and the user peer analytics has the peer metadata. So you can use this information in your hunting, building your detections. For example, if you see unusual behavior happened, for a user Alice, and you can see if this is also, who are Alice's peer? Is this normal? Among her peers. Then you can build higher fidelity detections using this information. Back to the okay. So the next building out of box threat detections is Fusion, and in the product documentation we call advanced multi-stage attack detections. Fusion combines suspicious activities, yellow alerts. We call yellow alerts. Most of them are low and medium severity alerts into high fidelity incidents. So lots of low, medium. Our security analysts are drawn into like enormous volume of data and alerts. Many low severity and the medium severity alerts are not, on their radar, right? So just like got there and no attention. So we use machine learning to stitch together those low and medium severity alerts and look for those compromises. I will give you some examples. This is the screenshot in the Azure Sentinel. I will show you a demo later. Okay, now this is the demo. I want to show you how it looks like. Okay, so we have one Fusion rule on the analytics in Azure Sentinel. And, if you read the description, there are total 70 Fusion incident types. So this rule is enabled by default. And currently, we are covering these signals. If you ingested your AAD IP data or MCAS data or MDATP or Parado networks data, then we are Fusion are looking through all the low and the medium severity alerts signals and stitch together and find those multi-stage attacks. So this is, like I said, this rule is enabled by default. You don't have to do anything as long as you have the data. It process your data in the back end and issue incidents. So this is our demo environment, and pick this one, right? So for example, this incident stitch 2 alerts, low fidelity alerts together. It says Microsoft, it's the one is that from AAD IP, one is from Microsoft Cloud application security. So what we found is a suspicious logging by Jeff from this location, which is the title say unfamiliar location. So we use behavior analysis. This is the signal, also use machine learning in AAD IP to find that this user, Dubring Island is unfamiliar location to this user, meaning, in the past, we haven't seen Jeff logging from that location. And then followed by, he deleted more than, 9,000 unique objects in a single session. And this is also an unusual behavior based on our, behavior analysis. So this looks like obvious, kind of mass destroying data, like maybe it trying to do some damage in your system. So that's one example. Another example is we stitch together MDATP, Microsoft Defender Advanced Signal, low fidelity signals. And on this one, it's say Azure Sentinel, but in reality is we look through Parado network firewall information and found, suspicious activities. So this one we saw there is a low fidelity alert in MDATP that's saying there is a suspicious remote WMI execution from this host and to this is the source host, admin host, and this IP address is the destination. So this remote WM key execution is issued to this destination. And we saw a Parado firewall activity that a connection from this host to outwards to a suspicious location, which Parado's suspect is a C2 activity. So if you stitch those together, there are things happening in your network. So those are the examples. And in reality, we actually, found a true positive incident. A customer told us that, oh, thank you, your Fusion identified virus was downloaded to a computer inside my corporate network. And that was another, MDATP plus Parado firewall scenario that we identified as host connecting to a Tor service, and then Parado network detected a potential virus. And then, the customer did, we issued an incident and the customer did an investigation and confirmed with us that's a true positive. So that's kind of the, from customer experience, how Fusion works. And another thing I want to show you is, if you come to here, right, and you click, we click in investigation or full detail, you usually will see two alerts. Severity are low, and these are the two alerts happened in the time window, and that really suspicious. And then you can also, click the investigate button, like you have the usual investigation experience in Sentinel to dig into these entities and to do further investigate. So that's how the experience in Fusion experience in Sentinel. Let's go back to the slide. So this is how Fusion works in the backend. Like I showed you the data layers. So you ingest your data into Azure Sentinel, then the identity data, Office 365 data, all these data actually like a multi-billion events per month. From Microsoft side, actually multi-billion events per day. We monitor so many activities in the entire world on Azure, right? And it's impossible if just human being to monitor them. And various Microsoft security products and also Azure Sentinel, we built anomalous, do behavior analysis and build those signals. But these anomalies are still like in millions. It's impossible for security analysts to zip through and find the needles in the haystack. So this is where Fusion comes in. We use graph-powered machine learning algorithms to build a hyper-connected graph, the nodes are the entities like user, IP address, hosts, URL, etc. And then the edges between the nodes are the activities happened in between those nodes. But this graph, with millions signals is super big, right? Then we use another machine learning random walk algorithm. Actually, is our customized random walk to walk through the kill chain. We call probabilistic kill chain, meaning we actually walk through all the possible routes, all the possible stages in the kill chain, and to trim the graph. Like, if this activity doesn't, follow certain kill chain, all these routes, then we just cut them off. So trim the graph to have a suspicious candidates like 200. Then we do a high final layer of machine learning and scoring all these incidents, all these candidates with the labels Microsoft available, and with the TI information, IOC we have, and with the past behavior. So then the incidents that above the threshold, we trigger an incident. So that's how backend the fusion works. And we've been monitoring how many incidents triggered per month. Usually, like in average, there are about 100 to 200 workspaces receive fusion incidents, and the average is like 1.5 fusion incidents per workspaces. So it's a high confidence and high fidelity signals. And if you see a fusion incident triggered, it's a high severity. So I highly recommend you do investigation immediately. So that's fusion, and there is that stitch mode, two low and medium severity signals together to find high severity incidents. And the next one is building anomalous SSH and RDP logging detections. The difference between this building detections and the fusion is, these detections just use a single source to detect anomalous loggings. For SSH, we use syslog, and for RDP, it's the security events. So let me show you. They are, if you look at, if I click the loot type, so those the loot types are ML behavior analysis. So those are the two another two detections we have. And you look at the description, we actually detect 3 different type of unusual activities. One is unusual IP, like this address have not been seen or rarely seen in past 30 days on this user account. Unusual geo and a new user. So we trigger detections on these 3 different scenarios. And we use 7 days data for training. So these 2 detections are not enabled by default. You can find them in the rule template, and then you can create a rule like you do with the scheduled rules. If you have data like a syslog, or you have data Windows event, you can go enable them. And we have a machine learning engine in the backend to monitor these signals. So these are the running in streaming mode, and it's a really real-time detections. You know, if we find unusual loggings, you get alerts, incidents in seconds. What we did actually is pretty complicated to make sure we give you high confidence, high fidelity signals for those data. For those signals, because you know, relying on single data source, it's, you know, usually it's pretty noisy. So what we did is this is show you like more details what we have done. The recurrent neural network machine learning algorithms, and we have this geolocation anomaly detection system in Azure Active Directory. We've been fine-tuning it in past 6 years. So this one is a highly complicated, advanced system in our AAD IP, my team built. And we have actually, it's a supervised learning, and we have team to like, you know, look at signals and providing labels. So, but in our customers' environment, we are not expecting you give us labels, right? Day by day. So how can we leverage our, you know, existing experience and algorithms and apply to your data and give you high fidelity signals? So this is what we do. We use the model compression and the learning transfer, and transferred this highly complex machine learning model to compress them to a model that can use down timestamp user and the location information, that logs that have those three information like a SSH log and RDP log, and can score this data and refer back to the learnings we learn in the AAD to produce those high fidelity incidents in your environment. So this deep learning and the recurrent neural network model resulted, you know, have a few very, you know, looks like very simple on your end, but there are lots of processing in the background for this. So that's another set of the machine learning detections in Sentinel we have. Like I said, currently we are having SSH and RDP, but you know, we're going to expand to other identity services like AWS Okta later. So that's the, I already showed you that. I don't have the incidents generated in my demo environment for SSH and RDP, but you know, you will see same fashion of incidents that you can show up in your incident list, and you can, you know, do investigation and look at the, you know, raw data to further investigate those alerts. So those are the current threat, machine learning threat detection we have in public preview and the GA in Azure Sentinel. If you have any like scenarios or threats that higher on your list that is not covered currently, feel free to send me, you know, tell us, you know, what's the high priority in your organization and your wish list that we can build out of box threat detections. So this is the Azure Sentinel product documentation page that documents in detail, you know, the fusion scenarios. It is categorized by threats. You can see, you know, like a computer resource abuse, credential harvesting, crypto mining, data exfiltration. These are the threats covered by Fusion. And you can see in every, for example, computer resource abuse, we listed the MITRE tactics and the techniques covered and all the scenarios covered. So like I said, we actually have 90 different scenarios now in public preview, and we need to update that description very soon. The description currently says 70, but we actually have 90 scenarios, and the documentation is up to date. So you can go through this, what are the scenarios covered by Fusion. Okay, now moving to bring your own machine learning platform. So, Microsoft, we are never going to cover every data source, every scenarios in our customers' environment, especially, examples like in the verticals, right? Like in finance or healthcare or energy. And, you have your own data, maybe don't want, we don't have the expertise in those domain, or we don't have visibility to your data. So, but you do want leverage machine learning to detect those 0 days or novel attacks in these kind of business case. And if you have data scientists in-house, then, we heard many customers like say, hey, yeah, I have data scientists, but, we really have challenge like building, high scale platforms that support those data volume, right? And to deal with, all the infrastructure problems. So this is the BYOML. It's the platform that integrates with Sentinel, and your data scientists or engineers can just focus on building the ML algorithms or threat detections. Then don't worry about the infrastructure. What we have, the platform is using the tools that everybody, all the data scientists are familiar with, like Python, Azure Databricks, Spark, and the Jupyter notebooks. And, you can write detections on these tools. So this is architecture of how this environment is integrated into Sentinel. So let's say you ingested your data into Azure Sentinel workspaces, Log Analytics, and the Log Analytics has an auto export feature in public preview. You can configure which table you want to export to Azure Blob Storage or Event Hub. And what we have done is integrated in Azure Databricks, with Azure Blob Storage. And then you can pick your data, export to the Blob Storage. And now in the Azure Databricks environment, you can develop your machine learning algorithm, test it, run the training model. And once you are happy with your result, and you can schedule jobs or run it in the streaming mode and scoring all this incoming data and send the results back to Azure Sentinel for alerts. So that's the flow of the BYOML architecture. So I have a demo video, but I'm not gonna actually play. Let me see how many minutes here. Let me just give you a quick view of what we have. So what we have is not only, give you the platform, but also we actually wrote examples, step-by-step examples on the GitHub. So this is the Azure Sentinel GitHub. And in the GitHub, you can see there is a BYOML folder. And in the folder, we give you, like this is the detailed instructions how to use this BYOML. And there are libraries, notebooks. In the GitHub, you can just download and use them directly. So for example, we provide a sample data and a notebook that use this sample data to see, to split the sample data for part of the training data, part of the validation data, like you will do in real life. And we have this training model, and we'll run the training with this algorithm on the data we provided. And then we have a scoring model, then score the events and issue the signals, alerts above the threshold, send it back to Sentinel. So this is like a comprehensive hello world example for BYOML. You don't need any extra data to run these notebooks in your environment. If you are interested using, BYOML, I highly recommend you go through all these, examples. And then we also publish libraries that, the utilities for you to use. And those utilities also used are in the notebooks. So with that, let's see the timing. Okay, I can just show you. And this is the video actually is published on our tech community. It shows you like a step-by-step. Let me just go through.
Sharon, are you still there, or did we lose audio?
Can you hear the sound when I play video?
No, I think it's cutting out your audio when you play it.
I see. I will skip this then, and this is I have a link. Let me hold on. So I have link on here, and you can click it and play this demo on your own pace, and there are very detailed command instructions, how to do export, and every single detail is in that demo. So that's what we have in the BYOML platform. Okay, I think that's all I have for this webinar. Let me see, we have any questions, unanswered questions?
Yeah, we've got a couple in here. I can raise them to you if you'd like. Let me scroll through and find the place we've left off. Do Fusion alerts work only from other portals, or does it query the data specific to pattern and create patterns for specific traffic and then trigger based on the anomaly?
Yeah, so currently Fusion covers the data source I mentioned. For example, I think it's in the Fusion Analytics. So Fusion currently looks for specifically the signals from those 4 products. Like I said, it actually also look for Azure Defender, the signals from these. If you have these signals, AADIP, MCAS, MDATP, Parado Network, and Azure Defender, then Fusion monitors all the low and medium severity signals from these products and trigger incidents if we find suspicious activities.
All right, great, thank you. Can you walk people through how to enable Fusion on an instance?
Oh, so Fusion is, like I said, Fusion is enabled by default. So you don't, there's no action to enable Fusion. As soon as you onboard this data into Sentinel, it's enabled. So if you can just, to see if a Fusion enabled in your workspace or not, go to Analytics, Active Rules, and just sort on the rule type, you will see Fusion, right? So if it's not enabled, then disabled, or you don't see Fusion in this active rule list, then go to the rule template. And then you can, it says in use, right? But if it's not enabled, then you can just enable it in a way that, I can't create a Fusion rule again because it's already in use. But it's not in use, then you can create a rule. Then like the regular scheduled rule, it will show up in the active rules.
Okay, great. What's the best way to search for IOCs across all log sources? For example, looking for an IP address across all log sources. Using search times out with the small timeout windows, and searching across all schemas one by one is time consuming.
Yeah. So that's a good question. I think we have entity behavior features here. So I would, suggest if you use the search functionalities here to search the, IP. Search for accounts, host, or host IP addresses.
Okay, great. We've got a question here about somebody's wondering if you can speak to SOC ML.
Oh, SOC ML, yeah. SOC ML currently is in private preview, and if you are interested, currently it's available in US regions only. So if you are interested in SOC ML, and let me know, and I can onboard you to the private preview. What we have is we have out-of-box anomalies that out-of-box anomalies that in, like I showed you, in the layers of data, and we use machine learning, build out-of-box anomalies, and then we have a user interface that showing you and then we have the user interface that enable the security analysts to configure the parameters in those what's going on in those ML models to fine-tune those anomalies. For example, we just give you an example, like unusual mass downgrade, sensitive documentation, right? So when you this anomaly, right? In this anomaly, we cover like 200 different documentation type, Word, Excel, GIF, PDF, etc. But if you are don't care about those image documentation, you only care about like the office documentation, and then you can say, okay, I don't mind, just don't show me anything about a GIF, right? So you can configure those, and also like, oh, this is threshold I want to adjust it, lower it a little bit, or make the threshold higher so I get less anomaly signals, then you can configure those without knowing, how to do right machine learning algorithms for that. So that's the feature we included in SOC-ML. So these, if you onboard the private preview, you will see the new rule types called anomalies, and we built a bunch of anomalies, and those anomalies that's going to a new table called anomalies. They are not triggering alerts nor incidents, because the concept of anomalies, you will see a new table, anomalies. The concept anomaly is we do behavior analysis, anything unusual based on the history of a user or a computer, or what applicable to anything is anomalous. And some anomalous activity has security context, some maybe not. But it depends, right? So then Fusion comes in. Of course, in the roadmap, we will fuse anomalies. And the Fusion comes in, we'll stitch all this information together and tell you, give you high fidelity incidents. But then you can also use anomalies to, in your investigation, or build your rule-based query, etc. And we will integrate all these anomalies in our entity pages and different features in Sentinel. But the SOC-ML includes out-of-box anomalies and a user experience for you to fine-tune those anomalies.
Great, thank you. We've got another question here. When will we be able to deploy Sentinel uniformly and completely via code? At the moment, we're relying on a third party and it's clunky.
Yeah, this is on the roadmap. Yeah, so it's my sister team is working on that, Sentinel. Yeah, by code.
Great, thank you.
Mm-hmm.
Do you plan to add an option to perform global operations such as mass enabling a lot of analytics rules or setting a logic app against multiple rules?
I think setting logic app on multiple rules is, I'm not sure that it's already, like, I see, it's a different team, right? But I don't know the schedule, but it's definitely, been working. The other one, mass operations. Yeah, I don't know. I don't have the answer. So I can get back to you later.
Okay, great. And anytime we don't have the answer off the top of our heads, that's a great situation to use our forums, which we can follow up offline, and I'll be providing the link to those in a minute. We'll do one last question here before we wrap up. How can we get alerts from Sentinel or act upon those alerts using SOAR for alerts or incidents based on Fusion, ML, or Microsoft Security? There's no option to use a logic app for these type of alerts. So there's no way to get the notification that I can see short of constantly looking at the console.
Yeah, this is great. Yeah. So like I showed you, currently is Fusion is in like one rules and 90 different scenarios, and you can't associate logic app playbooks to it. We heard lots of customer feedback about that. So we are spreading Fusion rules to individual scenarios, which means you will see 90 different Fusion rules. And then after we spread that, you will be able to attach playbooks to individual Fusion rules. So that's like in our roadmap plan. Let me know, you have different opinions or different ideas for a better, user experience on your end. But that's what we are working on it. spreading
Okay.
fusion rules to individual scenarios.
Great, thank you. All right, with that, and we'll wrap up here. So I've just posted, it kind of came out as a big ball of text there, but a list of our upcoming webinars. We've got several for Sentinel in the pipeline, as well as some others for Defender for IoT and Purview and confidential computing. So please check those out. All the details and registration are at aka.ms/security webinars. That is also where we will be posting the recording for this webinar shortly. If we were unable to get to your question in any way, please post it on our forums. Just put the link in there, aka.ms/Azure Sentinel community. And if you're listening to this after the fact as a recording, that's a great place to ask a question as well. Another thing you should check out is our Ninja training. This is basically just a compilation of kind of all the trainings and videos and blog posts, everything that we think is valuable for getting you to the deepest level of knowledge possible. So if you really want to go deep, that Ninja training is the place to go. All of these links, I know we're throwing a lot at you here, can be found at our one link to rule them all, which is aka.ms/security community. That's the landing page for our community, and basically anything else that we ever give out, you can find there in one way or another. So thank you so much for joining us. I want to thank Sharon for a fantastic presentation. I want to thank all of those who helped answer questions in the background. Most of all, I want to thank all of you for being part of our community, and we hope to see you next time.
Thank you.